Okay, I have a streams example. What I've done is, I'll first describe the problem. The problem is I have three computers. One has the source, and I'll say that's right here. That happens to be my Mac in Walnut Creek, and it's a desktop, of course. And then I have a second computer, which I rent from Amazon. It's an EC2 instance. It's the very smallest instance that I could buy. And then I store everything at Amazon's S3. So there's three locations. This one happens to be in Virginia. This one's in Walnut Creek, and this one's in Northern California. The pipes between them, this is rather slow. It's my Astound communication. And this is all that Amazon can offer. One of the attractions from Amazon is they have lots of pipes and lots of redundancies. So that's what we're dealing with, or what I was dealing with. My problem is that on this machine, I have a set of CD images. It's quite a few images. I get them roughly 3 to 4 times a year, and it takes me several days actually to, by hand, get those images up here on the S3 site. So what I wanted to do is get those images. It's for a website I'll show you in a minute. I wanted to automate that so I don't have to do anything by hand. Just take the CD, put it on the Mac, and have them land here so that when the website is ready, it'll just display them. So I'll show you the website. It happens to be something that I did for my wife's business. It's just a catalog, and it has, I don't know, many hundreds of images. The images vary in size. The largest one I remember seeing is in the area of 5 megabytes. The smaller ones for the, let's say, the full magazine flavored image is somewhere around half a megabyte. So let's just say an average of 1.5. I don't know what an average really is. Then I have 2 jobs. This is my next step. I use something that would call that down, that size, so it would come up on the page much faster than all of those, all that heavyweight image size. So that's not in the scope of my problem. So that's the site. I want to show you what I've done. I created a main control. I'll go from top to bottom, but it's really the bottom here that's the important part. The rest of it is all set up for either comments or some kind of an error message. This is the top. So you can see I pull in lots of, oh, that's not so large, is it? Let me see if I can do that better. Okay, that was the one. This is the wrong one. Okay, that's the bottom of it, and you can see these 1, 2, 3, 4 different piped streams, and I start with a source stream. In this case, the source stream is the set of URLs that point to the actual blobs or images. And they have a lot of other data around them that I have to get converted into something that S3, I like on S3. Then I pipe it to a split that just gets rid of I'll show it to you, but I think it's a carriage return or a backslash line feed. Doesn't do very much, but it's also a stream that then pipes in and converts it to something that S3 can understand. So that's my logic for converting it. Then I create the content, so I actually pull a stream up that points back at that source stream blob. And I get that all ready to upload, and then I finally do the upload. in terms of pipes and where things happen, all of this down through content is really fast. And then content is relatively slow. The actual uploading is very slow compared to everything else. So there's a big disparity and a big need for some kind of a flow control or back pressure in this. So I spent a fair amount of time doing that. One of my attractions for Stream was that it would fit in a very small server. Remember, this is the least expensive one I could buy. It would also, small meant memory size. Also, I could do things in a modular fashion or a very small pieces. Each one of these does one thing, and then construct it or build it so that it was easy to understand, and maybe reuse it. And then it's non-blocking, so it goes as fast as I can get things from there into here and out to here. So those were the attractions to Streams. Just to pop up at the top, to reiterate, I pulled in a bunch of modules. Some of those I wrote. Split is one I pulled off from NPM. That's the one that did the removal of the dash or the \n. It's right here. And then these are the ones that you saw later. This is one that I used because I was exceeding memory several times, and so I've had a lot of help from people here. But you won't see any usage of that. I've taken it out from the comments. And then I created handles. The handles, well, I'm sorry, handles is the wrong word. I created a bunch of functions just to assist error handling. And then I created a few functions to assist in showing the memory leaks that I had. I don't have very clever debugging capability. And then I print out the process PID so that I kind of know where I am if I want to see how much resource I'm actually using on this EC2 instance, this one, the server. So that's the control mechanism. I'll show you a few pieces. But before I go to the pieces, I'll tell you what I was able to do. There are, in this case, 249 images. And if their average size is a meg and a half, something like that, it's quite a bit to move. What it actually shows, I took some pictures if you want to see them later. I have them here. But it'll come very fast through the object stream. That's the conversion to what S3 understands in the format I like. But when it starts getting to content stream, it starts slowing down. So I can see the back pressure and the flow control, and I see that by the comments that you'll be able to see. I'll show you where the comments are in these individual streams. And I print all that out during the flow. So I can start to see patterns. The very big images, they kick off and they start to do the upload. But while there's time for the processor, I go back and I start launching other images for the same process. So I can start building up quite a queue. But eventually, things can overwhelm memory. That's where Streams really was handy. I actually streamed the image from my Mac into the EC2 instance, and during that streaming time, it's keeping the memory requirements very low. So let me show you a few of these.
What's S3?
I'm sorry?
S3?
S3 is the Amazon language for where the storage is.
What's the format of the original files? It's just PNGs and TIFFs and stuff.
I didn't hear you.
What is the format of the original files?
Oh, I stripped off what was metadata on the actual image. And it tells a lot. It tells, kind of describes the image itself. And then it comes along with a lot of Apple they're really file descriptors. And at the right side of it is the picture descriptor, the image descriptor. So it's that data and nothing more. It's just a big long file descriptor. Okay. So I'll start at the top. This is the one that after I stripped off that ending line feed, I end up with just lines of those file descriptors. And then I start to transfer those, or transform those. So that's why this is a transform stream. And then I have one, this is not asynchronous, but one URI builder for S3's format that I choose to have. That was really my definition, so that I could reuse it when I build the website. So that's what this does. And then it puts it back into, where am I? Well, here is the source URI coming in the transform one at a time. And here I store the URI builder output. So I've got two pieces of information and I put them both in an object called OBJ. And then I want to verify, did I really get it? And if yes, I push that, which is on the read side of this transform stream. And then here's some messages I don't use. But it could be that it's not there. So you can see I say, whoops, that one didn't convert right. And so I want to get this message. I have several of those that just don't fit any format. And so they're rejects for the file name. So I either get good or bad. Goods get pushed on the output side or the readable side of the stream, and bad don't go anywhere. I just log what they are, so I can see it. That's really the end of this stream definition. The next is key, because at this point I've done the transformation, and when I say next, it signals back to the stream, I'm ready for the next arrival source URI. Source URI right here. So that's the arrival flow control, the basic mechanism. I'm going to get out of this stream now and go to the next stream in the sequence you saw earlier. So now I'm ready to go get the content back from, in this example, sitting on the Mac. I have to still pull the image in. So I've been out there to get the file. Now I'm going back again to be able to pull the image blob in. This communication happens to be secure shell. So that was an application that I pulled off, a module I pulled off of NPM as well. In this, again, from top to bottom, you'll see a lot of the top part of the definitions are modules that I might use, and then again the handling of errors, and then the transformation. OBJ is my arrival for what's coming in. You saw me push from the last stream into OBJ, so that's the source. And then I set up some definitions inside of this transform, mostly to use what's up here and then to use in the later functions. I'll show you some of those. So I'm building a set of parameters that S3, the storage area, understands. And I'm going to send those parameters with the image in the next step. But first I have to build it, and that's the purpose of this stream. So I go through, well, here's a regular expression. I have something called 4 digits, happens to be a year. In this case, I went 2015, but the generalized case is just 4 digits, followed by a hyphen collection, and then it's got the website name .com. That's the bucket definition that's part of defining things for S3. Then I get the key, and that's on the right side, to your point, which is really just the definition of the image itself, or the location on the file, so that I can reuse that again. And then I set up some other parameters that allow for permissions and define where things go in S3, and then what kind of storage I want for S3. That's the end of setting up S3. Got a little more work to do. I check for errors, and I commented out some things I don't need anymore, and then I push that set of objects. The params object is what you saw me just describe. The image object has both the link of the image and the actual blob stream, but it's a stream. And then I think I pushed this, but I didn't really, oh, here it is, I took it out. You can't see it so well. How to move it over. Actually, it's just image object, so that's the end of the statement. So there's really not much more than to see. And then again, the next signals to the stream, go get the next input object that, coming in the arrival of the stream, but not before. So that's key. That's my flow control. So the push occurs, and now I can use it on the next successive stream. Yes.
Is where you get the actual, is the place where you get the actual image, is
Yes.
that in this section, or?
Yeah, I'll show you where it goes. Here, how that happens. It's right here on this thing called SFTP blob, and I'm going to show you that. But that's the only thing that really executes. Everything else is a variable or function above it, and it sends off a file name for a source and an S3. That's really the destination for S3, and then it's a callback that comes into this routine, and that's the end of the transformation. So now I want to show you this asynchronous go off and get the stream out of my Apple Mac, and that's part of the overall parameters. Okay, this is the one that's going to get the image stream and produce it. Again, back to this. The streams are living over here. In the last stream, we set up a secure shell path, and we said, we know exactly what the file name is here. Pull the contents of the image, which is the big blob, in that, let's say 1.5 gigabyte or megabytes, and pull it into the server. So that's what it's setting up a stream to be able to do. Okay. So again, at the top, I require a secure shell. This Mac helps me define all the security items around my Mac so that only I can do the secure shell. And then I set up some objects. For me, this was a kind of an epiphany. I had to be able to control the connection to my Mac. And if I didn't control that, which I didn't for quite a long time, that's what blew up my memory. It just kept hanging. All of these, everything accumulated. So say 249 sets of data, the images included, and all the functions seemed to be piling on. And eventually I blew up that little memory here. So being able to store things in this object and then getting rid of the session SFTP was important to controlling the amount of memory. Question?
Where was it piling up?
What was piling up?
Where was it piling up?
Oh, it was, see if I can say, this is my understanding, I'm not certain of it, but the evidence I saw was RAM for the total application continued to go like this. Every step of the way, that's where that memory printout was showing. I was just using more and more of the available RAM until I exceeded what was, no, this was on the server that it's pulling this way, and every one I pulled, it made the RAM get a little fuller. Finally, it exceeded what that RAM would do, and it just failed. Question? It was a nasty overflow.
And you had to control the connection to the network. You said controlling the connection.
Yeah, I use these nexts where the next is in the transform for control. The other thing that I did for memory control, you'll see it in a second, is I was able to break out these objects. I push things into the objects when I get a new connection or a new session. Actually, I only use one connection and 249 sessions. And then I kill the session when that stream does upload, and when the upload is finished, then I drop this session. So that's what pulled my memory back down. All right, so again, the export is make the image stream. It has a callback that gets passed in, of course, and it has an object. There's a lot of functions here that I put inside just to make it more convenient. I think I could work and make that prettier. But the end of it, again, is the important part. It says, are there any secure shell connections? And if there are not, go get one. And then I'll show you, that one says pretty much the same thing. After I got one, it makes this call, but I end up putting it in two places. If there's not a connection, because I only use one connection, but I have many sessions, then go out, and this says, go get another session, and that's one of the functions that are above. So now I've got connections, and I'm producing streams. Then I make the callback in the main function. That's this piece. Remember, coming into this stream, I had an object as a parameter or an argument, and I also had a callback. This is the invocation of the callback. The first is null because of error. The second is the destination for S3. And the third is the stream itself for the blob. And then it has also a second part of that object, the size. I don't really use the size, I just wanted to pass it along because at one point I care. That's the end of this stream. So now the last one. This one actually does the upload. I did find an S3-streams after looking around. One of the things I learned about S3 from Amazon is that it doesn't like node streams very well. And there's a lot of inconsistencies. I guess I would describe that mostly as they were there first or they just didn't pay attention to Node.
Why did you choose this?
That's the right question. Again, it took me a long time to find it. I used others that I could find on NPM. They all had issues, and I can describe some of the issues, but in essence, only this one used node flavored streams. All the others had some quirky thing that was more S3. There were other patterns where S3 would take multiple parts because I was moving such big chunks. There's an API for S3 that will take multiple parts up to many gigabytes. I didn't need that, but all the others had that in there, and it wouldn't let me use anything smaller, so they just weren't useful to me. This one finally did, and I sweated a lot over figuring it out and finding it. The stream itself, again, takes this input. The arrival is the object, and the output on this one is the write stream. So here's the S3S that's defined in this S3 streams. It creates a write stream. It uses the S3 session, which S3's API then can be invoked. And it passes along the parameters that we set up in the previous stream that told S3 what the source and target are and what to expect, the stream itself. And then it has an error. And then I wanted to time it to see how long it would take. So I just set a start. And then on finish, I had this little program or a little output that it said start minus whatever the current time is, so I could see the elapsed time, and I could see the size. So that gave me some sense for what it's really taking to move at that stage. Then I cleared some things out. Honestly, I don't know if I needed all that. And finally, the next, which was the flow control. And then, just for my peace of mind, I print this out saying I started this upload. Keep in mind there's a big gap between when this starts and it shows up and when it completes, because things are going from Walnut Creek to Virginia to Northern California, so just the wire time is significant, and then the fact that they can be up to 4.5, 5 megabytes in length. And that's it. So I'll go back to the first one. And at this stage, I'll summarize by saying it loops through. I can show you on my phone pictures of what I was showed for output. You saw some of the printouts along the way as each stream flowed through. I would see slow streams get initiated, but then a lot of the smaller streams say, I'm ready to go, I'm ready to go, I'm ready to go, and they might even complete. And then finally the long streams would kick in. So there's no sequence, it's just arrival on when things complete. So that's the pattern that I saw. And then I've been fighting limits. One of the limits I had was connection limits on my Mac, because most people probably don't want a large number of connections into their Mac. That limit for the Mac operating system is 10 connections. Well, I have 249 sessions, so I put the number 500 in that and got rid of one limit. The same for the EC2 server had limits. I had to fix some of those. And then I'm now struggling with another limit that's in another part of the secure shell software that I don't quite know, but I'm gradually working through it. So I'm most of the way through. I've had many iterations, and now I'm ready for questions. Yes.
So I just want to make sure I understand. You have a computer at home, an Amazon instance, and an Amazon storage instance.
Yes.
And you used streams to transfer images from your Mac at home onto the Amazon instance, and then from the Amazon instance into the data storage. The
Yes.
S3 instance.
Yes.
Okay. And you use streams the whole way through.
Everything is a stream. And everything is non-blocking except for that conversion that I talked about. It's a piece of code that I wrote that converts into the format that I expect for S3. Everything else, whenever it arrives, it gets dealt with. Yes. So next steps for me, I have these things to clean up, but I'd like to do this even faster and see what else I can do. This portion, and actually of the upload, it's embarrassingly parallel. Each one of these have no relationship to any other image. So if I could find ways that this could flow, and I could get them all going at once, that would be a win. So I think the child process will do that, I think. And I haven't done that. Let's spawn a child process.
They're not flowing at once.
Pardon me?
They're not flowing at once right now.
I didn't.
They're not flowing at once. They're not sequence.
Well, I mean, what I've done is I've launched all of these, but if I had more spigots to go out and get them all running in parallel, it'd be even faster. So that's what I'm kind of after, is more spigots.
How many spigots do you have?
One. Yeah. So, and Amazon has a whole bushel. Yeah, I mean, that's one of their advantages. But the software doesn't understand that. So if I can figure out how to spawn more output,
What's the limitation that you have to send out to get more spigots?
why do I only have one? Well, the software's point of view, it just says upload and it uses whatever's there. But I need something that would say upload 10 or 20 all at once. And they're all trying to get out, but because there's this one pipe, they all get bunched up at that pipe. So it's just, in essence, I think of it as multiple pipes. If I can make this Tinker Toy with many of these brownish tubes, I would do that. That's what I mean.
And that pipe is your connection to your server. Is your connection to that server?
Yeah, this is the server and this is S3, and I have one connection to it. And then I have all these different sessions, but they're all fighting for the connection. So if this gets filled up, then everything waits. So if I had multiple browns, I could do things a lot faster. This would never, I don't think that can happen because it's my Mac. But this could happen because S3 and Amazon is built that way. So that's what I did. Thank you.
Hmm?